Good morning, everyone. Before I start with my presentation, I would like to thank the organizers for the opportunity given to the JRC to be here today and present you the Safe and Sustainable by Design Chemicals and Material Framework and the European Commission recommendation to implement it. In my presentation, I will briefly touch upon the policy context to move afterwards to talk about important concepts of the SSbD framework. Then I will also mention briefly the case studies in which the framework was tested for the first time and the lessons learned so far. And I will conclude my presentation with the European Commission recommendation for the implementation of the framework. So we are very familiar about the EU Green Deal and the zero pollution, climate neutrality and circular economy ambition of the European Commission. And we are also very aware of the different action plans and strategies set in order to achieve these goals. Among the environmental strategies, the chemical strategy for sustainability aims at protecting the human health and environment. And for that, it sets clear objectives like driving innovation towards safe and sustainable by design, chemicals and materials, but also substituting the most harmful substances and phasing out the most harmful substances and substituting as much as possible substances of concern or otherwise minimizing their impact. And for that, the CSS identifies as a key enabler the development of a framework to set criteria for safe and sustainable by design chemicals and materials. In order to achieve this, the JRC first, make a revision of existing frameworks dealing with safety and sustainability aspects in the design phase, including initiatives from research, from academia, from industry, NGOs, and agencies, to identify the dimensions that are covered in these frameworks and also the aspects, indicators, methodologies, and tools in order to do the assessment. And capitalizing on that, the JRC developed the framework for the definition of criteria and evaluation process for chemicals and materials to be safe and sustainable by design. And that is the basis of the European recommendation, of which I will talk afterwards. But first, I would like to talk a little bit about some important concepts that are useful to remember in order to understand the framework and how it is implemented. And here in this slide, we have how the CSS defines the SSbD approach. It defines it as a pre-market approach, meaning that safety and sustainability dimensions need to be taken into consideration already in the design process of the chemicals, materials, and products, and not as it has been done so far afterwards when we need to place them on the market. And another important concept is that this has to be taken with the life cycle perspective. And that's the reason why the CSS identifies the SSbD as a key enabler to achieve the Green Deal ambitions beyond existing current regulations. Another important thing, we also mentioned already the objectives of the framework, that is drive innovation towards safe and sustainable by design, chemicals and materials, providing guidance in order to develop safe and sustainable by design chemicals and materials, but also to reduce the impact of these chemicals and materials to the human health and the environment by phasing out most harmful substances and substituting the substances of concern, and also making possible to do a comparative assessment for this objective. What the CSS maybe doesn't mention clearly is that here it's already making the distinction between new chemicals and materials. So here we should consider very strongly the design phase, but also existing chemicals and materials where safety and sustainability aspects are already, our requirements are already set in current 16 regulations. And that brings us to another important concept of the SSbD, that is the design. And here it's what I just mentioned, that the frameworks makes a clear, not distinction, but mentions that we have a design process, but also the safety and sustainability assessment, and that these two processes have to go hand by hand through all the process and integrate them into each other. So again, coming back to what I mentioned before, it's not that first we design and then once we have to put them on the market, we take into consideration safety and sustainability dimensions. And here, linked with the next one, the SSbD puts for the first time together the safety and sustainability dimensions as well. So that they have to be considered integrated into one in another and not working in silos as it has been done so far. Sustainability is defined as the ability of a chemical material to deliver its function without exceeding environmental and ecological boundaries along its entire life cycle while providing welfare, socioeconomic benefits, and reducing externalities. Quite long. And safety in the context of chemicals and materials is related to the absence of unacceptable risk for human health and environment. Safety, it's a concept that it's transversal to the sustainability dimensions. It's somehow considered in the environmental, social, and economic dimensions, but in the area of chemicals, it goes beyond that, and that's the reason why it deserves its own dimension as well. And last is the life cycle perspective, as it was mentioned before, that all these dimensions need to be taken into consideration through the entire life cycle of the chemical material. And that's the reason why the framework proposes a stepwise approach, starting from the hazard identification of the chemical material, moving them to the risk associated to these chemicals and materials during the production and processing phase of the chemical at the industrial cases, and then the same when with the final consumer application phase. And step 4 is the one addressing the environmental sustainability impacts. For each step, the framework provides information with regards to the aspects, indicators that need to be taken into consideration, methodologies and tools that can be used, and also proposes definition for criteria and evaluation process. I would briefly mention the steps and the aspects and indicators that are mentioned in the framework, but I invite you to go and check our technical report if you want to have additional information of the other aspects. So step 1 looks at the intrinsic properties of the chemical material in order to identify its hazard profile and to the different hazard classes: human health, environment, and physical hazards. The criteria of the SSbD is based on the CLP criteria for this hazard identification, and then it groups these chemicals materials in 3 different groups, aligning with the different group definitions in the CSS and in the Sustainable Product Initiative. So in Group A, we will have the most harmful substances, including those substances of very high concern defined under REACH. In Group B, we have the substances of concern as defined in, as I mentioned, the CSS and the Product Sustainable Initiative. And in Group C, we will have the other chemical hazard classes that are not falling in A or B. Here, I would also like to mention that in order to identify these intrinsic properties, and in line with what it has mentioned before, when we are assessing these chemicals in the design innovation phase, a tiered approach is proposed in order to characterize the hazards as data becomes available. This tiered approach, of course, it has high relevance in the step 1 because we know that it's very time, effort consuming, and there are a lot of tools available in order to predict the endpoints, but it's applicable for all the other steps as well. Step 2 deals with the safety in the occupational environment, considering the production of the chemicals materials, but also the processing and taking into account as well the end of life of the product in which the chemical or material ends up, if it is an industrial or professional setting. And here, in order to assess the risk, we have to consider the hazard, the conclusion of the hazard assessment done in step 1, as well as the exposure considerations in order to estimate the risk and therefore the safety. Similarly, it happens in step 3, but in this case, looking at the consumer application phase, consumer of the product in which the chemical or material has been incorporated. And again, here it's important the hazard identification of the chemical as well as the conditions on how the product is used. And the last assessment is the environmental sustainability that takes in consideration the impacts along the entire life cycle of the chemical material by means of life cycle assessment. And for this, the product environmental footprint impact assessment is the recommended methodology. This methodology recognizes a minimum set of impacts, 16 impacts that are gathered in 4 different aspects that are also mentioned in the chemical strategy for sustainability: toxicity, climate change, pollution, and resources. And with this, I finish my overview of the framework and its assessment, and I move to the first testing of the implementation of the framework in real case studies. The framework was tested in order to assess the feasibility and applicability of the framework, challenges and limitations that can happen when implementing it, needs or gaps with regards to data, but we also heard this morning about skills, expertise, tools, methodologies, etc., and also overlaps between the different steps. We ran the test in 3 different case studies. One was fully run by the JRC on non-phthalate plasticizers in food contact materials, and the other 2 by companies with the support of the JRC on non-halogenated flame retardants in information communication technologies, and another one on using enzymes in the scoring process of textiles. And here, some lessons learned or challenges, or as I like to see them, opportunities that we identified during the implementation of the case study very well, or we are aware of some of them because of the experience gathered so far, like data, we mentioned as well this morning, availability of data, publicly available data, quality when we are using especially different tools, different methods that in some cases might not be validated. Communication, for me, very important. I come from working on this many years, and one thing is having available the data, but very important how it's this information communicated upstream and downstream. Fair data, also important nowadays. Methodologies and tools, there are a lot of methodologies and tools, but more need to be developed, especially in areas where they don't exist, like for instance, of course, for a specific hazard endpoints, but also how we relate them with the application of the product, the functionality of the chemical, and also in some cases for specific areas where there are not a lot of tools developed related to products, and also training and availability of databases. I left the first one for the last, because for me it's the most important one. We are here, and this is what for me it's this paradigm shift that we also like to talk about, is the integration. Integration with the design, integration among the different steps of the safety, integration of safety and sustainability. There is a need of consistency, alignment with the definitions, terminology, scope of the different steps of the assessments, and as it has been mentioned, overlaps and complementariness. And this brings me to my last part of the presentation, that is the European recommendation for the implementation of the SSbD framework. That invites competent authorities, industry, and research and technology organizations to test the framework and to provide feedback in order to improve its relevance, reliability, and operability, to establish it in research and innovation activities, and with the results obtained to improve the framework and develop criteria. The recommendation proposed, it's a 2-year period testing phase that will include the reporting period in 2023 and 2024. The one in 2023 started beginning of May and will last until end of June, and similarly will happen next year. And after that, a workshop will be organized end of each year to provide methodological guidance based on the input collected. And after this 2-year testing period in 2025, we will start with the revision of the framework and definition of criteria for safe and sustainable by design chemicals and materials. Here, just the structure of the reporting template. It has 4 different sections. I would like to mention that none of them are mandatory questions, only the ones related to the information with regards to who is the data or the feedback provider. And only section 3 is related to the implementation of the framework in a real case study. Therefore, I invite you, even if you don't have case studies, to download the reporting template and to provide as much feedback as is possible. And also with regarding to the case studies, even if your case study is not finalized and you cannot report all the information that it's included in the reporting template, it could give us an idea of what to expect for next year, if that's the intention of you to report next year on the case studies, and also potentially to provide some support in this year with regards to its implementation. My last slide is related to, and always forget mentioning it, but the JRC, of course, doesn't work in a silo with regards to the SSbD and its implementation or its operationalization. And this is a joint work with, together with RTD, of course, PARC and IRIS. And in this context, and related to what we mentioned about the needs to developing new skills, together with PARC, the JRC is organizing the first SSbD Bootcamp that has been launched and that will happen in end of October this year in Ispra, Italy. And as I mentioned, it has been already launched, and people that it's interested in participating can apply by the 30th of June. Additional information you have in the QR code and also in my last slide with information with regards to everything that happens in the context of the SSbD. Thank you very much.
Thank you very much for your presentation. I hope it gave you all a illustration of what this whole framework is about. I think when we remember the morning talks we had, it addresses both the need. We need capacities, we need skills, we really need to train, we need to be able to work across silos. So it's different scientific aspects who are brought together. I also hope that this framework for many of you will set I won't say there's no rocket science in it as such, but it's applying the things which we know, but in a different way and combining them differently. So if we all put our forces into it, and if we really make use of this testing phase we have now over the next 2 years to really, put our minds and our brains into it and provide feedback, and let's have discussions about how it can be improved, I think we can make something which has a valuable difference for everybody. I will just see if there's any question from the audience at this stage. Yes, please. Do we have a microphone, or do I need to give you?
Thank you very much for your presentation. My name is Gregory Moore. I come from the Swedish Chemicals Agency, and I work in the area of nanomaterials and a few other things. My question to you is that during this testing phase, you mentioned about pre-marketing and so-called new chemicals and new materials. Are you then inviting people to actually submit their information on how to deal with chemicals which aren't known and are not recognized by REACH at the present? Because if you are asking for that type of information, as I understand it, that would be a different way of tackling the testing or trying to identify, as you call it, the intrinsic hazard properties. I'd just like to know a comment. Is your testing phase actually going to be open for really pre-marketing chemicals and materials? Thank you.
Yes, actually, that would be the ideal. The thing that we face, even when we were running our first testing phase, it's that it's a very long run project. Usually it's difficult for already existing chemicals on the market that you're supposed to have all the available information. For us, it took more than 1 year to do and to run this testing, these case studies. But the idea would be, of course, to learn more about these really new under development chemicals and how industry or researchers are tackling the availability of information, how they are generating all this information, not only when we are talking about intrinsic properties, but also information with regards to how we estimate the exposure of the processing, but also of the application, and of course, very important, all the sustainability impacts as well. So that would be great, and that's the reason why I was also mentioning that we know that it takes a lot of time, but if we have a little bit of idea, it's always more than welcome. And as Sophie was saying, there will be time to discuss, and this is not that it's going to end in 2025, so, but it's the first step.